Good day, everyone. Welcome to Valenzuela Facebook live streaming in Mathematics 10. We are now in quarter 3, week 2. I am Mary Jane P. Messia, your live streaming teacher for today from my son, National High School. I hope that you will lend me your ears and stay with me until the end of our lesson. Let me and your math teachers know that you are tuned in by sending in your heart reacts. And let's start to learn and to love math. So join me and we will learn together the solving problems involving permutations. Write your queries that are relevant to our discussion. You can type or keep them in the Q&A part of this lesson. To begin with, let me give you first learning target of this topic. At the end of the lesson, you should be able to solve problems involving permutations. Like I said last time, solving mathematical problem is as easy as my name, Jane. J stands for just set your mind that every problem has a solution. A, analyze and understand the problem carefully. And need to know the given and what is asked in any lesson in math, like solving problems involving permutations. E, enjoy solving problems involving permutations. Now, let us answer first the activity, what's in. You have to evaluate the given factorial notation. The score that you will gain in this activity can be doubled plus additional points or bonus points once we reach the mission possible activity. So, keep your focus and make sure that you jot down your score. Choose the like emoji, heart emoji, wow emoji, and haha emoji. I will give you 10 seconds to answer each questions. Are you ready? So let us start. Number 1, 4 factorial. In like emoji, we have 4. In heart emoji, we had 10. In wow emoji, we had 12. In haha emoji, we had 24. Okay, the timer starts now. Okay, time's up. What is your answer? Very good. It's haha emoji. Because if we expand the 4 factorial, we have 4 times 3 times 2 times 1, which gives the result of 24. Number 2, 3 factorial plus 2 factorial. In like emoji, we had 12. In heart emoji, we have 8. In wow emoji, we had 6. In ha emoji, we had 2. Okay, set the timer now. Okay, time's up. What is your answer? If your answer is heart emoji, you are correct. Value of 3 factorial is 6. Added to 2 factorial value, which is 2. The sum is 8. Number 3, 7 factorial minus 5 factorial. In like emoji, we had 2. In heart emoji, we had 42. In wow emoji, we have 4,920. In haha emoji, we have 5,040. Okay, set the timer now. Time's up. What is your answer? Good job. It's wow emoji. Get the difference of 7 factorial value and 5 factorial value, which is 5,040 and 120. The result is 4,920. Number 4, 5 factorial times 2 factorial. In like emoji, we have 240. In heart emoji, we have 120. In wow emoji, we have 10. In haha emoji, we have 3. Okay, set the timer now. Okay, time's up. What is your answer? Amazing, you got it right, it's like emoji. The value of 5 factorial is 120 and 2 factorial is 2. Get the product of the two, the result is 240. Number 5, 7 factorial divided by 2 factorial. In like emoji, we have 5040. In heart emoji, we have 2520. In wow emoji, we have 120. In haha emoji, we have 2. Okay, set the timer now. Okay, time's up. What is your answer? Excellent. It's heart emoji. The value of 7 factorial is 5040 and 2 factorial is 2. Get the quotient of the two. The result is 2520. So there are situations where choices are to be made. And in some cases, the order in which choices are made is important. For example, a president and a vice president are to be elected from a group of students. So this situation is called permutation. Permutation is an arrangement or listing in which order or placement is important. Now, let us have the permutation of distinct objects or things. Suppose you want to form two-digit numbers from the digits 1, 2, 3, and 4 with a condition that no digit is to be used twice. How many ways can it be done? If we list down the numbers, we have 12, 13, 14, 21, 23, 24, 31, 32, 34, 41, 42, and 43. And if we count, we have 12 ways. So observe that there is an order in the way the digits are placed, since you are required to arrange the digits 2 at a time from the given 4 digits. So this situation can be translated as permutation of 4 objects taken 2 at a time. In symbol, permute 2. In general, n permute r denotes the permutation of n things taken r at a time. The formula can be written as n permute r is equal to n factorial divided by the quantity of n minus r factorial, where 0 is less than or equal to r is less than or equal to n. Now, let us apply the formula in a given problem. N is equal to 4 and r is equal to 2. Hence, 4 permute 2 equals 4 factorial divided by the quantity of 4 minus 2 factorial. Simplify the denominator. We have 4 factorial divided by 2 factorial. Expand the factorial notation in the numerator and denominator. We have 4 times 3 times 2 times 1 all over 2 times 1. Then simplify. The result is 12 ways. There are 12 numbers formed when the 4 digits are arranged 2 digits at a time. And it's the same in our previous answer. Using formula is the easiest, fast, and accurate than listing. So let us apply in example number 1. How many ways can we arrange 8 different books choosing 4 books at a time in a bookshelf? What is the value of n? Very good. N is equal to 8. How about the value of r? Correct. R is equal to 4. Substitute the value of n and r to the formula. We have 8 permute 4 is equal to 8 factorial divided by the quantity of 8 minus 4 factorial. Simplify the denominator. We have 8 permute 4 is equal to 8 factorial divided by 4 factorial. Expand the factorial notation in the numerator up to 4 factorial, since our denominator is also 4 factorial. Note, you may stop expanding the factorial notation up to the factorial notation that are the same in the denominator that can be cancelled out both. Okay, now, cancel 4 factorial. So what left are 8 times 7 times 6 times 5. And the answer is 1,680 ways. Example number 2. How many ways can first, second, and third place be awarded to 5 runners. The value of n is 5 and r is 3. Then substitute, we have 5 permute 3 is equal to 5 factorial divided by the quantity of 5 minus 3 factorial. Simplify the denominator, we have 5 permute 3 is equal to 5 factorial divided by 2 factorial. Expand the factorial notation, we have 5 permute 3 is equal to 5 times 4 times 3 times 2 factorial all over 2 factorial. So we stop in 2 factorial since our denominator is also 2 factorial. Then cancel 2 factorial. What left are 5 times 4 times 3. And the answer is 60 ways. Example number 3. How many ways can 3 boys and 4 girls be seated in a row of 7 seats if the girls insist on sitting next to each other? First, you may consider of seating a group of girls in a row followed by boys. Then, a boy may occupy first from the row followed by the group of girls and the 2 boys. Or 2 boys may occupy the first 2 seats from the row followed by the group of girls and a boy. Or the group of boys may occupy the first 3 seats from the row followed by the group of girls. So observe that girls may occupy the first from the right of the available 4 positions, considering that girls sit always next to each other, and may also occupy the second, third, and fourth positions, knowing that they are grouped together while boys are occupying the other 3 seats or 3 positions. Thus, the arrangement you will consider is G or girls, B sub 1, B sub 2, B sub 3, where G is the group of girls which is counted as 1. So therefore, in that situation, the formula is 4 permute 4 is equal to 4 factorial divided by the quantity of 4 minus 4 factorial. Simplify the denominator, we have 4 factorial. The 4 factorial value is 24. Note, this is just one of the considerations. Remember that girls may rearrange themselves. The number of ways where girls may rearrange themselves, but still they are occupying the consecutive seats will be 4 permute 4 is equal to 4 factorial divided by the quantity of 4 minus 4 factorial. Simplify the denominator, we have 4 factorial, and the 4 factorial value is 24. Since there are 4 seats available for them, and all of them may sit anywhere as long as they are grouped together, therefore, the total number of ways of arranging 4 girls and 3 boys in a row, where girls sit next to each other, is 24 times 24 is equal to 576 ways. Now, consider another instance when you are asked to arrange identical objects or things. For example, find how many different 4 digits number which can be formed using the digits in 3665 or 3665. If all the digits are distinct, you should be able to find 4 permute 4 is equal to 24. But since the digits are not distinct, it is not enough to use the first formula. You may denote the 6 as 6 sub 1 and 6 sub 2. If we exchange the places of 6 and then remove the subscript, you will get 3665 or 3665 as identical numbers. Apply the same concept of removing subscript in 6 sub 1, 3, 6 sub 2, 5, and 6 sub 2, 3, 6 sub 1, 5. Notice that you have the same number, 6365 or 6365. Hence, we don't have 24 different numbers. You can only get half of 24 numbers, which is 12. So, see on the screen, the list. As you can see, we have identical numbers. cross out the identical numbers, then count the remaining numbers. And it is true that we have only 12 we get after we form 4-digit numbers using the digits in 3665. This situation is called permutation of identical objects or things. The number of permutation of n objects where k of them are alike is given by n factorial divided by n sub 1 factorial times n sub 2 factorial times n sub 3 factorial and so on up to n sub k factorial, where n is total number of objects and n sub 1, n sub 2, n sub 3, and so on up to n sub k are numbers of identical elements. To find the distinguishable permutation of identical objects, use this formula. In the previous problem, the values of n is equal to 4, which is the number of objects, and n sub 1 is equal to 2, because we have 2, 6. N sub 2 is equal to 1, because we have 1, 3. And n sub 3 is equal to 1, because we have 1, 5. Can be substituted in the formula. So permutation of 4-digit numbers where 6 are alike is 4 factorial divided by 2 factorial times 1 factorial times 1 factorial. Expand the factorial notation in the numerator up to 2 factorial, since our denominator is also 2 factorial. Cancel 2 factorial. What left are 4 times 3 because 1 factorial is 1, then simplify. The answer is 12. Different 4-digit numbers. So we can make the denominator of our distinguishable permutation simply by writing only the permutation of those objects that appear more than once. We may not write the permutation of the object that appears once because 1 factorial is equal to 1 and any factorial multiplied by 1 is equal to the given factorial. So let us try in example number 1. So how many different permutations can be made out of the letters of the word Masaya? How many letters in the word Masaya? Very good. 6. How many letter A? Correct. 3. How many letter M? Great. 1. How about the letter S? Correct. There is also 1. And lastly, how many letter Y? Good job. There is 1 also. Then substitute to the formula, we have permutation of the letters of the word Masaya is equal to 6 factorial divided by 3 factorial. Expand the factorial notation in the numerator up to 3 factorial, since we have 3 factorial in the denominator. Cancel 3 factorial. What left are 6 times 5 times 4. The result is 120 ways. Example number 2. Robert plans to visit his grandma's house, which is located at the other street in their village. He walks in the south or east direction. Below is an illustration of the street in their village. So how many possible routes are there from Robert's house to his grandma's house? To go from Robert's house to his grandma's house, he must walk 2 blocks south and 5 blocks east can be substituted in the formula. Permutation of possible number of routes from Robert's house to his grandma's house is equal to 7 factorial divided by 2 factorial times 5 factorial. Expand the factorial notation in the numerator up to 5 factorial, since our denominator is also 5 factorial. Cancel 5 factorial, then simplify. The answer is 21 possible routes. Now, let us consider another instance when you are asked to arrange circular objects. For example, Ami, Bella, and Carla would like to sit in a round table during the birthday party of their friend Dindo. How many possible ways can they be seated? Which of the following arrangement are distinct and are the same? So see the scenario of the arrangement on how they can be seated in a circular table. So look at who is on the right and on the left of each girl. Notice when you rotate the girls in clockwise direction, there are arrangements which coincides with the other. So this kind of arrangement is called permutation of circular objects. In a given problem, observe that table 1, table 2, and table 3 represent the same arrangement. Notice that Bella is always on the right side of Ami, whereas in table 4, table 5, and table 6, where Bella is on the left side of Ami, also represent the same arrangement. To determine the number of circular permutations, we should consider one object fixed and calculate the number of arrangements based on the remaining number of objects left. The number of permutation of n objects around a circle is given by the quantity of n minus 1 factorial. The arrangement in this problem can be done by fixing one object in one place, like Ami, and the other objects are permuted as shown on the screen. So we have two ways to arrange the three girls in a round table. So let us solve using the formula. We have the quantity of n minus 1 factorial. Substitute the value of n. We have the quantity of 3n minus 1 factorial. Simplify. We have 2 factorial. Expand the 2 factorial. We have 2 times 1. And the result is 2 ways, which is exactly the same of what we got earlier. Now, let us try example number 1. How many ways can 5 children ride a merry-go-round? What is the value of n? Very good. N is 5. Substitute the value of n to the formula. We have the quantity of 5 minus 1 factorial. Simplify. We have 4 factorial. The value of 4 factorial is 24 ways. Therefore, the number of ways arranged in the 5 children ride a merry-go-round is 24 ways. Example number 2. How many ways can John, Michael, Leah, and Sarah be seated at a circular table if Leah and Sarah insist on sitting next to each other? Here, we can fix the girls in one place and 2 boys may rearrange themselves. There are the quantity of 3 minus 1 factorial is equal to 2 factorial ways in this arrangement. But the girls may also shift their positions. Thus, there are 2 factorial ways. By multiplication rule, there are 2 factorial times 2 factorial is equal to 4 ways of arrangement. Now, your turn. So let us answer the activity Mission Possible. Before we start with your mission, be ready with the score that you get from the activity What's In. Your mission is to open the safety box by answering each permutation problem correctly. Choose the like emoji, heart emoji, wow emoji, or haha emoji, corresponding to your answer. If your answer is correct, your score in activity What's In will be doubled and will be given bonus points. If not, your score remains the same. At the end of the activity, your accumulated bonus points will be added to your score. You have 10 seconds to answer each question. Are you ready? So let's start. Mission Possible number 1. How many different permutations can be made out of the letters of my first name, Mary Jane? In like emoji, we have 181,440. In heart emoji, we have 90,720. In wow emoji, we have 15,120. In haha emoji, we have 2,520. Okay, set the timer now. Okay, time's up. What is your answer? If your answer is heart emoji, you are correct. See the solution on the screen. And because you are correct, you can collect the bonus points. So let us check what is in the bonus points. And the bonus points is 5 points. To those who are incorrect, don't worry, we have 2 remaining sets of questions. I hope this time you will answer it correctly. Now, let us move on to the next question. Mission possible number 2. How many ways can 8 people be seated around a circular table if 2 of them insist on sitting beside each other? In like emoji, we have 360. In heart emoji, we have 720. In wow emoji, we have 1,440. In haha emoji, we have 5,040. Okay, set the timer now. Time's up. What is your answer? Very good. It's wow emoji. The solution is flash on the screen. 2 people sitting together is considered one element. Number of ways of sitting 7 people at a round table is equal to the quantity of n minus 1 factorial. Is equal to the quantity of 7 minus 1 factorial. Is equal to 6 factorial. Is equal to 720. But for each way of arranging the 7 people, there are 2 factorial ways of arranging the 2 people who insisted to sit beside each other. Thus, total number of ways is equal to 720 times 2 factorial is equal to 1,440 ways. So let us check for the bonus point. The bonus point is 5 points. Now let us move on to the next question. Mission possible number 3. In a tongue fiesta singing competition with 12 contestants, how many ways can the first, second, and third place winners be determined? In like emoji, we have 132. In heart emoji, we have 990. In wow emoji, we have 1,320. In haha emoji, we have 1,716. Okay, set the timer now. Time's up. What is your answer? Excellent. It's wow emoji. The solution is flash on the screen. So let's take a look at the bonus points. So the bonus points is 5 points again. So congratulations, you completed the mission. Be honest to report your additional score to your follow-up teacher so that she or he can record your score. So, and if you have some questions regarding the lesson, feel free to type in the comment box. So these questions will be answered later. So let us now summarize the lesson. So how do we find the permutation of objects? The permutation of n objects taken r at a time is denoted by n permute r, and also given by n permute r is equal to n factorial divided by the quantity of n minus r factorial, where n is greater than or equal to r. The permutation of n objects taken all at a time is given by n permute n is equal to n factorial. So how do we find the permutation of identical objects? The number of permutation of n objects with n sub 1 identical objects of type 1, n sub 2 identical objects of type 2, and so on, and n sub k identical objects of type k is given by n factorial divided by n sub 1 factorial times n sub 2 factorial times n sub 3 factorial, and so on, up to n sub k factorial. How do we find the permutation of circular objects? The number of permutation of n objects arranged in a circle is given by the quantity of n minus 1 factorial. Okay, this time, I will entertain some questions from our viewers. So let me ask the assistance of our moderator. So I think our teacher moderator did not receive any questions from our viewers. So this time, I want to leave these questions for you to reflect. So how are you going to arrange the following based on your priority? Number 1, hobbies. 2, family. 3, friends. 4, study. 5, love life. So you can pass your answer to your follow-up teacher. So we can now proceed to your home learning task. And for your home learning task, see on the screen. Okay? Thank you for joining me today. This is Ma'am Mary Jane P. Messia from my son, National High School, saying, keep on practicing and spread the love of learning. Keep safe and have a nice day.